So the other day I went to use my mill. I was making an oiler for the RV dump valves, and I went to turn on the VFD and it just smoked, popped. So I took it apart and I found that the bridge rectifier in it, for whatever reason, shorted. Don't know why. Nothing else was wrong with it. I didn't have the full size 220 volt 3-phase rectifier, but I did have a single phase 220 volt bridge rectifier. So I kind of hodgepodged that one in, and today I'm going to I hodgepodged that one in, put the VFD back on so that I could finish my project. And today I'm going to take the VFD back down and replace the hodged in, or the fudged in bridge rectifier out, and put in the one that I ordered. So stay with me, that's what we'll do. Okay, so we have a Huanyang 2.2 kilowatt VFD that blew the original bridge rectifier. Don't know why it blew the original bridge rectifier, but it shorted the AC coming in. So I had another bridge rectifier, much smaller, only a 10 amp, not a 30 amp, in stock, and I kind of fudged getting that in. Actually, I don't think these have to be removed, if I recall. So I can get down to those screws. Let me see real quick. I think I just have to remove this ribbon cable. Use my ball head. Let's see. Okay, just move that aside. Actually, real quick, I'll put the screw back in. So I was right in the middle of building a oiler for the RV dump valves, and I got done with all the lathe work, went to the mill to mill flats into it, and hit the power switch, not this switch, to apply power, and the VFD just sparked. Blew the circuit breaker, actually melted foil off the board, which I'll show you when I get this board out. So I just had a little 10 amp. I had to bend the leads all funny. I don't know if you can see in there, but I bent the leads all funny to replace this one temporarily to get the job done. So let's see how we do getting this out. Basically, this is the screws going down to the heat sink for all the MOSFETs and the bridge rectifier. Kind of a really odd setup to the way this thing comes apart. It wasn't designed to be worked on. Come on. And I don't have 220 on my bench, so to try it, I could get it to power up with 110 with my variac turned all the way up, because it'll over voltage just a little bit. Alright, so let's see, which one do I have not? Must be this one. There we go. They're all off. Gotta shift it a little bit this way. Get this one off. Shift it a little bit this way. Get this one off. Doesn't really need three-phase in, because this is three-phase AC coming in with DC out. It doesn't need that, because we're doing single-phase 220 to three-phase fan. All right, so we can put the heat sink away. You can see the smoke, and this is how I really hodged in a friggin' little 10 amp bridge rectifier. And here's the trace that got burnt. Liquefied that trace. But let's see how we do trying to get this one out. Get a little solder on the tip of the gun. They're pretty big holes. Okay, let's see if we can get this puppy to come out. Had to do some really whack stuff to get the leads to bend over. To go where they had to. So there's a lot of tension on them. What's holding you now? There's that one, and then one more. like I said, I only had a 10 amp in stock, so that's what I had. See if we can get these holes cleaned up at all. It did run it though. I ran it really slow and gentle. Took light cuts. And it is a design for a, this is supposed to be designed for a 3 horsepower. So, and that mill out there is only 2. So, shouldn't have a problem with it. Oh, this is going to be a problem. That's the wire I replaced. It vaporized that trace. Took me a while just to get all this cleaned up down here because it was all covered in soot. Let's see if it fits now. Couldn't find the exact same part, so I got a close representation of it. So hopefully it's close enough. That's pretty tight. There's that one. That one. There's closer. I think this hole still has something in it. Let me see. There it goes. All right. It's in. Height looks pretty good. Oops. Height looks pretty good until I just jammed it in there. Hopefully I don't bump you guys. Check, check. Drop the recorder. Come up. There we go. Alright, so this has to go. I can't really solder that in until I get it mounted on to the board. And I want to clean all this bad heatsink compound off. Heatsink compound somewhere. I don't think it was any of this the cause. I think it was just a faulty part, to be honest with you. But I gotta basically put this in, mount it, solder it, and then take it back out so that I have the bridge rectifier set to the right height. And then just looking for thermal compound. So I'm not going to put that on just right away. I'm going to put this all back in. Hold it right. Put that one bolt for that in. Make sure everything is lined up right. Make sure there's nothing under it. All looks good. Okay. Still feels like it's got a little bit of a flex on it. We don't want any, oh, it might be the wires. Basically, you don't want any tension on it. Okay, now we unbolt it. Pull it back out, and we have to deal with this broken trace right here. So basically, all I did was I soldered that from the back side. Okay. Just gonna hit this joint a little bit. Looks a little dry right here. Okay. That one looks good. We're all good there. So now we make sure nothing else is touching. Put this back in here like this. We have to shift this off to the side. Oh wait, before we do this, I always screw this up. These screws have to be in their respective holes and ready. Where'd the other ones go? That's for that. Okay, that's still there. That one's still there. Wait a my other one go? There it is. All right. Basically, you have to have these into these transistor holes because in their brilliance, the washers don't fit through the hole in the circuit board. This is what I mean. This is not designed for maintenance. Although I will say this insulator that they have does help hold the screws. All right, so we got all the screws in there. That's got a bolt. I don't want to get this heatsink compound everywhere, so I imagine this is a temperature probe. The wrong size Phillips. This is how they had the ground, so hokey. Okay, this fan unhooked. Don't want to screw up this wiring. Where's my other screw? What did I do with it? That was the wrong screw. This is going to be the one that goes to the actual bridge rectifier. Those are going to be the two that go in here. Not that that really matters all that much, but might as well just do it right. Don't like the curl on that anymore. Okay. Check all our screws are still in there. All right. A little heatsink compound. Hate this stuff because it gets all over you, all over your tools. Okay, got a good coating of it. That screw fits for some reason. Okay, got that one. All right, now this is a chore. I didn't bend them this time. Last time I had to bend them to clean under them, and it became a wicked pain to get them all lined back up. This one feels like they're going in pretty good. Let's just take a look. Those all look good. I'm just getting them started, and I haven't tightened any of these yet. Just make sure they're all down, threaded in. Okay. Screw holes should all reasonably line up. Let me loosen that just a little bit. Look good. Got some scored out with the heat transfer compound. Make sure these transistors are all tight. If it looks high, kind of at an angle. Let me get a smaller screwdriver. Hopefully I don't bump you. I think I'd have a smaller one. I bumped you, sorry. That one's tight. Because you know if these aren't heat sinked, those will definitely go. Okay, that all looks good. Set that aside. Fan wire is good. Okay. Those all go like that. Now, it's not going to be able to start. It's just going to it's just going to power up and say low voltage because it's supposed to have 220 input. Works in a terrible environment. It's dusty, metal fragments, grinder is right next to it, so it works in a horrible environment. Let's see if we can get this. I don't know, that's only like everybody's gonna yell at me for using this. Everybody thinks I'm gonna electrocute myself. If you watch today, I do. So we're just looking to get power. Really doesn't matter which of these three you hook up because it's a three-phase thing, a three-phase input. So basically any two wires are going to create DC. So it really doesn't matter which one you use. Okay. I'm going to use a dim bulb just to make sure it's not shorted. This is very high DC voltage, so you got to be careful when doing this. If you're not comfortable working with AC, don't. Okay. Plug into the isolator. Plug into here. Make sure this is off, 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 off. Okay. Plug in our display. Our display is going to read low voltage. When we turn it on, hopefully no sparks. We'll go 40. It takes it a second. Just as I was about to give up on it last time. Okay, came on. Low volt, that's low voltage. So the fix worked. Means it is working. Not obviously not shorted because the bulb's not lit up even on a 40-watt bulb. So that means we're good. We can shut this off. Unplug this stuff. And turn my light back on. Take these wires back out. This is a forward reverse switch, just so if you're asking. I didn't like hitting the buttons on there. Okay, so I think we're good. Oops, let me turn that back down so I don't fry something else. Turn off the isolation transformer. All right, so we're going to set this aside. We're going to go out back out in the garage and meet back up. I'm really surprised this little 10 amper worked, and we'll go from there. Be back in a jiffy. All right, so welcome back. I've got it all back in, wired up. Let's turn it on. Well, that's a good sign, no sparks. Turned on. Okay, that's the frequency. We'll turn it way back. Turn it up a little bit. Go forward. You can see that the thing is spinning. I don't know if you can see that or not, but it is spinning. Shut it off. Put it to reverse. Yep, the frequency up. Brake was a little stuck. Turn it down. Check the e-stop. Okay. Well, there you go. That's replacing a bridge rectifier and a Huanyang 2.2 kilowatt VFD. Thanks for watching.